or perhaps even more common, just passing objects to other people. And the fact that we can perform some of these actions from early on in life also, of course, raises questions about, what the processes are that are sort of minimally required to perform joint actions, and whether, or to what extent you can implement joint actions also in situations where you don't have two human partners, but a human and a robot. And then one other aspect of joint action that makes it interesting, at least to me, is also that it's quite fascinating at times to watch joint actions. So a lot of us have this fascination with, watching activities where people show high degrees of coordination, whether this is soccer or tango dancing. And so recently I've also become interested in this question of why it is, or what it is about joint actions that makes us sort of interested in watching them and sort of getting a particular aesthetic experience out of that. So I'll hopefully come to this at the very end. The basic question that has driven a lot of my research is simply the question of how people manage to perform joint actions. And as I said before, often we don't think about this because it seems so trivial and so mundane, and we just do it. But once you start thinking about the perceptual and the motor processes and the cognitive processes that are involved, things actually get pretty challenging. Now, historically, there have been a few ingredients that people have identified. One is the unique human motivation to engage in cooperation and also to experience commitment once we have started doing something together or promised to do something together. So Mike Tomasello and his team have performed a lot of research showing that even though other species also are quite cooperative, humans really stand out and have this strong motivation to share intentions and to do things together. In philosophy of action, this has also been a prominent topic. And in particular, people there have identified shared intentions as a key component of joint actions. So there's a lot of disagreement as to what shared intentions really are, but there is some agreement that shared intentions do play an important role in guiding joint actions. And it's sort of interesting once you start thinking more about this, because how is it possible for you to intend something that you're not going to do alone? So you're sort of intending actions that will be performed by other people. And this raises a lot of questions about the nature of these shared intentions. And then another key ingredient that Herb Clark has highlighted is, of course, language or discourse, which in and of itself is a form of joint action. So as we are talking with each other, we normally take turns and we try to, maybe achieve some kind of common understanding, which is a sort of joint project we may have. And at the same time, discourse also functions as a very important coordination device. So often when you're doing something with someone else, like assembling some furniture, you may use language in order to coordinate. And on the one hand, it's sort of impressive how we're able to do this. On the other hand, it can also be, very limited. And there are also, many situations where you can easily see how language doesn't get us very far when it comes to coordination, especially when we have to be very fast. So if you're playing basketball with someone, let's say, it might not really help to explain, where you're planning to go next. It's much easier for the other person to just observe your body and make predictions on the basis of that. Now, these more basic mechanisms of perception and action, and in particular perception-action couplings, have been highlighted by work that comes from a dynamical systems perspective. And there, the focus has been very much on emergent coordination processes that may also be contributing to joint actions. These are processes that are very, very basic and that we probably share with many other species. And the idea here is simply that you have an informational coupling that leads to coordination. So when you put two clocks on the wall, they may synchronize because you have a physical coupling. And likewise, when you put two or more individuals next to each other, because they are sharing information about each other's actions, you can have something like an informational coupling. And the idea is that this can give rise to coordination phenomena like a school of fish moving in synchrony, but also people in rocking chairs synchronizing their rocking, or people synchronizing their body sway while they're having a conversation. Now, even though these ingredients have been identified, it's clear that they're not sufficient for explaining many of the joint actions that people perform. So on the one hand, you have these sort of quite high-level theories about, shared intentionality and our motivation to cooperate. On the other hand, you have these very low-level theories that are about coordination processes that are very, very basic. But there's a lot that needs to be happen in that needs to be happening in addition to that to explain how it is that we manage to perform a piano duet together, or that we manage to move some furniture together. And so my research has basically tried to identify the mechanisms that we need in order to account for how it is possible for people to perform joint actions. So in the rest of this talk, I would just like to highlight some key principles that we've identified over the years, and then give you always, one or two studies as an example. So one first principle that has sort of shown up quite prominently in many different studies is that people have a very strong tendency to integrate the actions of their task partners into their own planning. And this is a little bit different from an idea that was already around in philosophy earlier, which is that, of course, you take other people or other people's actions as constraints in your planning, and you're planning your own actions around them. So what we're arguing here is that you're not just planning your actions around other people, but you're literally planning other people's actions as if they were your own. And this allows you to achieve a high degree of coordination. So to make this more concrete, let me show you one study that we ran a few years ago. This is a study that was done by Dimitris Kurtis, who's now a lecturer at Stirling. And he used EEG to look at what happens when people prepare either for joint or for individual action. And we compared 3 different conditions here. In one condition, people simply lifted a glass and moved it as if they were about to clink it with another person, but the other person wasn't doing anything. So it was a solo action where they were just moving one arm and lifting the glass and placing it back again on the table. In the joint condition, as you can see in the picture here, the other person was also doing their part, so they would clink their glasses together. And we compared this to another individual condition where the clinking of the glasses was being performed again by a single person. So they would take both glasses, move both of their arms, and clink the glasses together. And we were particularly interested in what happens in terms of action preparation. So what happens before people are actually starting to move. And for that reason, we used a cueing paradigm. This is quite a common method in studies of individual motor control, and we extended it to a joint setting. So we gave people different perceptual cues. They knew what these cues would stand for. So they saw a shape and knew that the shape meant, act alone or act together, use one hand, use 2 hands, and so on. Don't do anything was also a cue. We wanted a no-go baseline. And then after 1.5 seconds, they received a go stimulus telling them to now perform the action that they had prepared for. Now, what can we expect for this action preparation interval? If people are simply planning their own part, then we would expect that the unimanual action condition and the joint condition should be similar, because in both cases, people are grasping one glass and moving it. However, if what people do is that they're planning both contributions to the joint action, we should actually see that the joint action condition and the bimanual action condition are similar, because in both cases, you're planning 2 components of one coordinated action, right? So you're planning 2 different things that need to be in a certain relation to each other. And to look at this, we focused on the CNV, the contingent negative variation, which is, at least in its late stages, considered as a marker of motor activation in the brain. And we already knew from earlier research that we can expect a higher CNV amplitude when people plan to perform a bimanual action compared to when they plan to perform a unimanual action. So we know that when there is more complexity in the motor plan, and when there is coordination required between 2 limbs, the CNV amplitude is normally higher. And this now allowed us to ask what would happen in the joint condition. So if people are planning both contributions in the joint condition, CNV amplitude should be similar to the one that we see in the bimanual condition. If they're only planning their own part, it should be lower. And here you see the results. So we see this build up in the CNV, so build up in motor activation prior to the go stimulus. And what you can see here is that the joint condition in bold is right on top of the bimanual condition, that's the dashed line. And the amplitude was quite a bit higher than in the unimanual condition, where people were just preparing for single action. So this tells us that even though from a motor point of view, the joint action was really similar to the unimanual action, right? Because people were only moving one arm. In terms of action preparation, we see that they were taking into account the partner's action because they were preparing just in the way they were when they were preparing to move their two hands. So that tells us that there is at least, a particular stage in action planning where people seem to be integrating their partner. And we also got, sort of similar effects with regard to how people allocate their attention in the bimanual, in the joint context. So if you're interested in that, that's also in that paper. Now, I also wanted to show you a behavioral study that's making a similar point. And in particular, this study tells us that people care about a partner's task constraints. So here's an example. You're walking down the street next to your friend, and there is this obstacle in your friend's way. So it would be well advised for her to lift her foot higher than she normally would, take a bigger step to step over this obstacle. Now, you don't have an obstacle in your own path. You could just continue walking the way you normally do. But if you plan the other's action, and if you care about, the other's environment in which these actions are being performed, it could actually be that there is some sort of contagion where you yourself are lifting your own foot higher, even though that's not really necessary. That was the basic idea that we wanted to explore here. And in the lab, we came up with something that's a little bit different. So no walking was involved, but lifting something over, lifting a dowel over an obstacle, on having no obstacle in the way. And we were particularly interested in the participant who did not have an obstacle. So all the data I will show you are data from participants who had no obstacle in their own way. And what we compared was how high they would move in order to reach a target when their partner had an obstacle or when their partner did not have an obstacle. So was the partner's obstacle making them move their own arm higher? That was the basic question we wanted to address here. And we did this in a series of experiments where we varied whether they were facing each other or sitting next to each other. And more importantly, we also varied whether or not they could see each other. Because if we see that they are considering the other's obstacle, even when they can't see the other, it tells us that this must be more like a sort of top-down effect that has to do with their representation of the other's task or task environment. And what we see is indeed that people move higher when their co-actor has an obstacle compared to when their co-actor has no obstacle. So the black lines are the ones where are from the conditions where the co-actor had an obstacle in her way. And the dashed lines are without vision, so where people could not see each other. And I think it's really interesting that there's absolutely no difference between seeing and not seeing your partner, because this tells us that the fact that people were moving higher really must have to do with them thinking about what their partner is doing and imagining the object in the other's way, perhaps, and is not the effect of some kind of more low-level visual motor interference or so. Okay, so this is some evidence, just some examples that people care about what their task partners are doing and are integrating predictions about their partner's actions into their own action planning. Very much related to this is another principle, which is that people have a tendency to care about the outcomes of their joint actions. So their planning actions and also monitoring actions with regard to the joint outcomes that they are trying to achieve. And to give you an example here, I chose a study where we looked at pianists duetting together. This is a study that was performed in the Netherlands, so a few years ago, by Janine Leur, who's now a professor at the University of Saskatchewan. And she specifically had these pieces composed so that they would, sort of fit with our research questions. And we asked the pianists to practice their part at home, and then they would come into the lab together. So each partner was playing one part, so one the treble part, one the bass part. And as you can see, it was a very sort of simple piece where they were just playing chords quite slowly. So it was again an EEG study, and we wanted to make sure that there was enough time in between the chords that they were playing. And they were good pianists, so they wouldn't really make any mistakes. But what we did is we simply inserted mistakes. So we inserted violations as a way to measure their expectations. So as they were playing their parts, every now and then we would insert a wrong note. And we could do this because they were playing on a MIDI keyboard, so we could simply change the feedback that came from the key they were pressing. It's a little bit nasty, but we did tell them in advance, so there was no surprise. And what we manipulated was two things, actually. One was whether the violation occurred in their own part or in their partner's part. And that gives us an indication as to whether they mostly anticipate just the tones that they are going to produce, or whether they also anticipate the tones that their partner is going to produce. So if we see some kind of, reaction to mistakes in the partner's part, this tells us that they are sensitive to errors in the partner's part and are monitoring the other's part and having these anticipations. And the other thing that we manipulated was whether the tone violated the joint harmony or not. So you can replace the tones in such a way that even though it's a different tone, the joint harmony is preserved, or you can insert a tone such that the joint harmony is changed. Now, importantly, when we changed the joint harmony, we always did it in such a way that it was musically still very much expected, and it also sounded nice. So whatever we see cannot be a consequence of people hearing something that's, very unexpected or funny or strange or aesthetically unpleasing. So I hope that's clear. So we manipulated, either whether the violations were in people's own part or their partner's part, and whether there was a consequence on the joint harmony or not. And then we looked at error processing, or sort of processing of these violations. Not really errors in a traditional sense, since they were not made by people themselves. Okay, so when we look at an early component of error processing, the FRN, which normally occurs about 200 milliseconds after the violation, we see that people were sensitive to these violations. So there was a reliable FRN whenever a tone was not as expected. And there was absolutely no difference between conditions. So it didn't matter whether it was in their own part or the partner's part, whether the harmony was affected or not. But more interestingly, there is a difference when we look at the P3, which has more to do with how people evaluate these errors. So this tells us more about what people make of the violation. And as you can see, there was a main effect of self. So people cared more about violations in their own part compared to the partner's part. So here, positive is up. But there was also an effect of the joint harmony. So the largest response to violations occurred when the joint harmony was affected. And there was a slightly smaller response when the joint harmony was not affected. And you can see this especially when you look at the partner's part, where basically there was only a reliable sort of P3 response whenever the joint harmony was affected. So people seem to have some kind of hierarchy in their planning, if you will, where they do care most about, what it is that they are going to do next. They also care about what their partner is going to do, but they especially do so in the context of joint outcomes. And they seem to care less about, individual outcomes that their partner is producing. We recently took up this idea and studied this in a pretty different context, not with musicians, and in a task where people just played a game where they had to produce particular hand shapes. And I won't go into detail here. Feel free to ask me about this study later. I just wanted to point out that what was interesting about this study is that we had one condition where we simply told people about the relation of their actions. We just told them what you are going to do will be the same, or what you're going to do will be different. So they didn't actually know what exactly they would have to be doing with their hand. They didn't know whether they would, move their palm sort of facing outwards or inwards. They only knew about the relation they would be in with the other person. And that in and of itself already facilitated planning and led to motor preparation. So again, this is just sort of indirect evidence that people really care about relations between actions and joint outcomes, and even do this when they don't know what exactly their individual actions will be. So just knowing they will be doing the same or something different can already guide their planning. Okay, so that was pretty short-term planning where, you're just making a plan for grasping a glass or moving your hand or playing a tone on a piano keyboard. What about planning a whole course of action? We recently got quite interested in this issue, and as a sort of first attempt to look more at sort of, decision-making in the context of joint action, we wanted to know whether people would care about efficiency from a joint perspective. So if you imagine that, you know, we are in better times and you're out in the park trying to meet a friend and you want to sit down somewhere, if you're coming from opposite directions, you have quite some choice here in this example, right? And so if you're feeling a little bit tired and or lazy, and you don't mind your friend doing all the work, you might just take the very first bench and have them walk all the way towards you. Or you might feel that, you know, it would be a really nice gesture to walk all the way to your friend and not have them walk very far. Or you might actually figure out which bench would minimize the walking distance for both of you. And that would be, you know, sort of suggesting that you care about joint efficiency. So you care not only about your own movement costs or a partner's movement costs, but you care about the sum of your movement costs. So you care about the joint effort. And so Gina Törek, who's a PhD student in my lab, finishing soon, came up with a task where she used a touch screen, and people simply moved the ball to their partner. So the partner was standing opposite of them, and they could choose whether to move left or right. So on the touch screen, they only saw these you know, these openings and these obstacles. They did not actually see the red and the green line that you see here. This is just for illustration purposes. So if you're the participant here and you want to pass the ball, you can go left or you can go right. If you go left, it's shorter. So if you want to minimize your own movement cost or your own time, if you will, then it would be a good idea to go to the left. However, if you do go to the left, it means that overall for the two of you, this is the longer path because your partner has to travel quite far to pick up the ball. If you go to the right, you're taking the long path out of the two that, you know, sort of you can choose from. But overall, this is the shorter path for the group. So this is what we call an incongruent trial, because by taking the long path, people would minimize the overall distance for the group. On a congruent trial, when you take the short path, this also happens to be the shorter path for the two of you. So things are good. And we also included neutral trials because we wanted to know whether, given the same path length for the group, people would have a preference to be selfish or to be altruistic. So this gives us a sort of baseline to see what people normally prefer when nothing is at stake in terms of joint costs. And we ran this in a couple of different versions, but the basic finding is always the same. And the basic finding is that people indeed minimize joint movement costs. So in the congruent condition, they take the short path because that's also the one that's shorter for the group. In the incongruent condition, they tend to take the long path most of the time because that's the one that's shorter for the group. So if they had just acted selfishly, they should have chosen the short path in both of these conditions. And if they, had a strong tendency to be altruistic, then they should have taken the long path in both conditions. But rather than that, they seem to be very sensitive to the combined costs for the two of them. And we see that in the neutral condition, they're not quite a chance, but they have a slight preference towards being nice with their partner. This is a very simple task where it's really easy to compute the distances because you could simply imagine performing the whole movement yourself. So even though you're passing the ball, you could compute the length of the movement path by imagining you were performing the whole movement. So we recently also came up with a modified version where computing the sum of the distances, or the costs, if you will, is sort of requires a separate computation for yourself and for the other, where you basically need to add up the costs. So this is a version where you're moving from this octagon and you decide whether to go to the circle or the square. And whatever you do, your partner then has to collect the matching object. And that gives us more flexibility to see, how sensitive people really are to differences in costs and whether, to what extent they have this sort of altruistic preference. And in this version that we're still working on, we replicate our findings. So we find that people are very sensitive to joint efficiency. We don't really replicate this slight altruistic preference that we saw earlier. If anything, people act a little bit selfishly here. So it seems as if, when it's not very clear to them which movement path is shorter overall for the group, they act a little bit selfishly. And when it is clear, then they go for joint efficiency. Okay, so to summarize this part, I've shown you some studies suggesting that people have a tendency to consider the actions of their task partners and also related environmental constraints. Their action planning and monitoring is guided by representations of joint action outcomes. And they also consider what is efficient in terms of movement costs from a group perspective. Now, this was very much about making predictions about other people's actions. It's also important to consider what people can do to make their own actions more predictable to others. And that's also a sort of blossoming little research field within joint action research. And in particular, people have become interested in a phenomenon that's known as sensory motor communication. The idea here is that you can make your own actions more predictable to other people by changing the ways in which you act, and in particular by exaggerating certain movement parameters. So for instance, here's a study by Sakeli and others, where they looked at how people are grasping an object. You would grasp it with a precision grip if you would grasp it at the top, and you would grasp it with a power grip if you were to grasp it at the base. And when they introduced a setup where one person knew where to grasp the object and the other person didn't, so had to be informed, then the person who was knowledgeable started exaggerating things. So this person made their precision grip a little bit smaller and would also move higher in order to indicate I'm going up. And likewise, when they had a power grip, they would move lower to indicate that I'm grasping the object at the base and not at the top. And you could easily imagine this happening, for instance, in a situation like the one here, where you have, the salt and pepper, and you could move in a way where it's really easy for a partner to see whether you're grasping the salt or pepper, or you could imagine someone moving in a way where that's not so easy to tell. So even when people are not speaking, there are ways in which they can make their actions speak. And we looked at this also in the context of music performance, specifically because we were sort of interested in whether this exaggeration of movement is something that's unique to situations where you're demonstrating something to another person, or you have knowledge that the other person doesn't have, or whether this is also something that just helps people in the context of coordination. So if you're trying to reach somewhere in synchrony, then can this exaggerated movement trajectory also help you become more precise? And so this is work by Luke McAllen, who did his PhD a while ago and is now a postdoc at Warwick. And he came up with a virtual xylophone task. Let's see if I can get the video to play. Right. So there was a motion sensor, sort of attached to the mollet that he was using. And he was simply hitting a table, but we were sort of, online figuring out where people were moving and playing the tones accordingly. And we had people do this in a situation where they were just demonstrating actions to someone else, or a situation where they were trying to coordinate with someone else who was also holding a mollet, and they were trying to play the melody in synchrony. And we always had an individual baseline where people were just doing this on their own. And very much, in the same way as people showed in other contexts that were more about informing others, we also see here that when people demonstrate these new melodies to someone, they move higher. So maximum height is higher in the joint condition compared to the individual baseline. We also see that they are doing this in the context of coordination. So this is not unique to demonstrating actions. It also occurs when you're trying to coordinate with someone else. And interestingly, when you look at movement velocity, there are some aspects that are unique to coordination. So we found that people were slowing down specifically when they were trying to coordinate, but not when they're demonstrating these actions. So there are subtle differences between demonstration and joint action, but perhaps more importantly, we showed that this exaggeration of movements is something that happens quite easily, both in the context of demonstration and also coordination. Okay, now when you have two people mutually predicting each other's actions, this can, both be beneficial for coordination, but also lead to particular experiences. And I just wanted to mention a study here by Leo Noy and others that they ran a few years ago that tried to understand what's going on in the context of joint improvisation. So here they used the mirror game. Maybe some of you are familiar with this. So this is basically an exercise from improvisational theater. And in the sort of regular mirror game, you would use your hand, you would, face a partner, and then your task would be to try and move in synchrony and produce interesting movements together and enjoy playing. It's actually, if you try it out, it's not that easy to do. And what normally happens if you don't have expertise as an improviser in some domain, what happens is that you end up being in a leader-follower pattern where one person is moving faster than the other and the other is trying to catch up. And their movements end up being a little bit jerky and not very well aligned. So there is a prediction issue. And of course, this is a situation, even though it's quite minimalistic, where prediction is very, very difficult because we're in a context of improvisation, right? So you don't know what your partner is going to do next. It's not easy to predict. And therefore you get these sort of jittery movements of the person who's trying to follow. However, what Leo Noy and colleagues were showing is that if you look at experts who have a background either in music or dance or theater improvisation, they have a way of predicting each other's actions that allows them to get out of this leader-follower dynamic and to predict each other in a way where the coordination can be very smooth. So what you see here on the top is, just an example of the way people are coordinating when there is a leader and a follower. So you see the leader in blue, sort of performing smooth movements, and the follower in red, being more jittery and sometimes being a little bit behind and sometimes a little bit ahead of time. Whereas in experts, they identified these periods of what they call co-confident motion that are pretty much jitterless and very impressive to look at. So you see that people are moving in this very, very smooth way, and you don't have anyone leading and anyone following. It's more like they're sort of both leading or, well, just performing these movements confidently. And they also played around with the instructions and found that novices did better overall in terms of being synchronized when one of them was assigned to be a leader and the other was assigned to be a follower. But in experts, it was the other way around. So experts did better when they were not in this leader-follower dynamic, and they managed to produce these periods of co-confident motion. And they explained this in terms of a model where they proposed that people are mutually predicting each other. So you could sort of say, if you take the building blocks that we talked about before, that what we know is that people predict each other, people make themselves predictable for each other. And then if both people are, trying to make themselves predictable for each other and are predicting each other, this can be sort of a mark of expertise and something that people are perhaps sort of working towards as they are trying to be more and more coordinated. There are also more simple forms of synchronization outside of the context of joint improvisation that anyone can engage in, like, for instance, walking in synchrony. And I recently got quite interested in these forms of, joint actions, in this synchronized behavior, because there's a lot of literature suggesting that there's a whole host of pro-social effects of acting in synchrony. And at the same time, it's also something that we like to observe. So I just want to give you two quick examples. One comes from a study we collected just before we left Budapest. And this was a study with Gray Edgerton and Liam Cross, who are now both at Edge Hill. And in this study, we wanted to know whether walking in synchrony with someone could reduce negative attitudes towards them if they're members of an outgroup. So in Hungary, there's a big minority of Roma Hungarians. And we know that the non-Roma Hungarians tend to have a lot of stereotypes against them, showing up both in implicit tasks, but often also in explicit tasks. So there's also explicit prejudice against them. And what we did was simply that we had a Roma confederate, and we had these Hungarian participants who came and either walked in synchrony with the Roma confederate or walked at their own pace. So they were both given a metronome and then walked at their own pace, or they would walk with matching steps. And before and after they did this, we measured both implicit and explicit attitudes. So for the implicit ones, we used the IAT. For the explicit ones, we used a bunch of questionnaires. And what we found is that acting in synchrony did have a positive effect. So it did lead to a reduction in negative attitudes, very clearly for explicit, but also, to a smaller extent, it was also true for implicit attitudes. And to some extent, this also worked when people were merely imagining to be walking together. So the effects were stronger when people were actually walking next to each other, but just getting people to imagine that they were walking in synchrony with an outgroup member also had a slight beneficial effect. And we're sort of now planning to do a lot of follow-up studies to better understand, what drives these effects, under what conditions can we find them, and to what extent is this really about synchronous performance, whether just something doing highly coordinated together. Okay, and then finally, I want to turn to this aspect about joint action perception and sort of aesthetic experiences that we have when watching synchronized movements. So Luke McKellen also did a study where we tried to show very minimal cues to coordination and then asked people to make judgments about the perceived coordination. We asked them what they thought about these people that they were observing in terms of affiliation, and we also asked about their aesthetic experiences. So we again here relied on the mirror game that I was talking about before, on this sort of simplified version by Leo Noy and others, where you just have a slider that's moving back and forth along a track. And so we got people to move these sliders, and then we actually artificially generated stimuli that looked as if two people had been playing together, but everything was under our own control. We're these, type of cognitive psychologists who want to have a lot of experimental control. So we just had individual movements and then put them together in different ways to see, what would drive people's perception of the joint action in terms of coordination, affiliation, and aesthetic experience. And in particular, we manipulated two things. One was asynchrony. That's a very obvious thing to do because we predicted that people would prefer synchronous movements over asynchronous movements. And the other thing that we manipulated was a cue that was directly taken from the work by Noy and others, and that was jitter. So we also, independently of asynchrony, manipulated the amount of jitter in the movements. And there was also a follow-up study where we used a different sort of very subtle movement parameter, but for now I'll just focus on the jitter. Now, let's see if these stimuli, if these videos work. Yes, so as you see, there were just two moving dots. We told our participants that these reflect the movements of two people who were playing this kind of mirror game together. And what you see here is a condition where the asynchrony was high. Here's another example that looks a lot better. So this is low asynchrony and also low jitter. We didn't have perfect, synchrony because that would look artificial. We always tried to be in a range that seemed sort of plausible. And in the last example, you're going to see what looks like an interaction that has this kind of, jitter problem where you have a leader and a follower and they're not quite aligned. And we showed people many different instances. Sorry, playing all over again. Okay, so here are the results. What we see is that overall the results are very similar regardless of whether we ask our participants to tell us about what they think in terms of coordination, so how well coordinated were these two people, or whether we ask in terms of liking, how much do you think these people like each other, or in terms of aesthetic experience. And the pattern is the following. There's always an effect of asynchrony. So there are higher judgments for low asynchrony compared to high asynchrony. So people think that when there's low asynchrony, there's better coordination. They think that these individuals like each other more, and they also give higher aesthetic ratings. So they find it more pleasurable to watch these interactions. But what we also see is that jitter plays a big role as well. So we also have a main effect of jitter, and people prefer low jitter over high jitter. What we don't know at this point is whether this is just about a sort of preference for low jitter as such, or whether this is really something specific about the social interaction. So we would like to make the claim that people prefer social interactions that have low jitter, but I think we need to run some follow-up experiments to really make that point. So I think this is of course just the start, but it does show that, you know, sort of perhaps a little bit similar to the old Haida and similar approach, you can show very minimalist cues and elicit quite rich interpretations and judgments of the social interaction that is being observed. And we're sort of particularly interested in following up on these aesthetic judgments to see, you know, to what extent people really have a preference for synchrony, and is it a preference for synchronous movements? Is it also a preference for synchronous pauses? And is there perhaps a point where too much synchrony is just boring? So often, especially in the context of improvisation, you also want, you know, difficulties and you want failures. And it's particularly exciting in a way if people, you know, are no longer coordinated, but then manage to find each other again and to be in synchrony again. So there's a lot of, you know, potential for follow-up studies here. Now, to summarize these last few studies, acting in synchrony has effects on our pro-sociality, on affiliation and empathy. And based on that, we conducted this study with Hungarian participants and Roma outgroup members to show that acting in synchrony can also reduce negative negative attitudes towards outgroup members. And studying joint action observation, we found that observers enjoy watching joint action performances or joint improvisation performances where actions are synchronized in this sort of continuous manner and with low asynchrony and with low jitter. And that already brings me to the conclusions. So to put this into, you know, back into sort of context of our lives, I think joint actions are actually a really fundamental part of human social life. We engage in them from quite early on. Initially, the joint actions we have as, you know, babies with our parents are quite asymmetric, of course, and largely scaffolded by the adults, but eventually we become more proficient at being proper sort of joint action partners with others. And once that is the case, we see that people have a strong tendency to include the actions of their task partners in their planning. People care about joint efficiency, and they care a lot about joint action outcomes. So this tells us something about the hierarchies in people's action planning and their sort of, yeah, the flexibility and their ability to go very easily from an individual perspective to a joint perspective. Perhaps, you know, a bit different from other domains where this is more effortful and also more error prone at times. We've seen that action prediction is involved in many different coordination tasks. It's often beneficial. It can be facilitated when people are making the actions more predictable. And there is some evidence to suggest that mutually coupled predictions are especially beneficial and are also a mark of expertise. And I think there's still, you know, more work needed to show whether synchronization is really as special as some people think it is. But we do know that joint actions that involve synchronization can have these pro-social effects and are also appreciated by spectators. So I would like to acknowledge the funding that has unfortunately just run out, my grant from the European Research Council, and also my, you know, now very long-term joint action partner, Günter Knoblich, with whom I've been doing a lot of this work. And of course, all the collaborators and people in the lab about whom you can find out more on our website. So thanks a lot, and I hope you have tons of questions.
Great. Thank you very much. You were right. Shorter than 1 hour and very clear. So I open the virtual floor for questions. There's a couple of questions in the chat already. So if you want to read them, Natalie, and answer them verbally while the other people prepare the questions, that'd be great. Can you see it, or?
I'm just trying to see it. No.
Shall I tell you?
Yeah. Oh, I see. It's under more. It wasn't showing on my options. I see. Okay. Would you need to determine the threshold for jittery low synchrony versus not high synchrony? If so, how would you do it? Yes, indeed. So what, I think the question here is what counts as, sort of low asynchrony, or what counts as low jitter. So we took our values more or less from the initial paper by Noy and others. So we just sort of looked at what people naturally do and took that as a basis. And I think what I didn't mention, what's perhaps interesting, is that our spectators, so our observers of these joint actions, were actually novices. So they were not people who had an improvisation background, and yet they seemed to be quite sensitive, even though the jitter was not, super pronounced. And also I think the asynchronies were fairly subtle. So that perhaps points to an interesting dissociation between what people are able to do and what they're able to detect in others. So yeah, I think our threshold basically came from these sort of human data, but there may be ways to sort of go about this in a more systematic way, more like a sort of psychophysiology of synchronization almost. Yeah, we could sort of determine at what point people are even able to detect asynchronies or jitter. Okay, let's turn to the next one. And of course, tell me if I haven't answered your question, if there's more to it. There was a question about synchrony and prosociality. Synchrony promotes prosociality towards out-group members. Do you know if people might generally have higher synchrony with in-group members? Aha, that's interesting. So the question is, does group membership actually, if you put that on the independent variable side, does that affect how synchronous you are? I'm not really aware of any work that has done this. There's some work showing that if you're acting with an in-group member, you have a stronger tendency to care about their task and their actions. So there are these studies where you set things up in a way where you have your own task and you should ignore your partner. And then the typical finding is that you cannot ignore your partner and you're taking their task into account anyway. And that has been done in the context of, having an in-group or an out-group member as your partner. And there people have found some evidence that you care more about the actions of an in-group member. But that's a bit different from the question of, whether you would see better synchrony. And yeah, it's an open question. I think it would be interesting to show this. I would guess that if you find it, it would have some sort of motivational origin, right? Where you're not trying as hard, perhaps, to make yourself predictable or to predict your partner if it's an out-group member. And that would also then suggest that since you are achieving lower levels of synchrony, you don't quite get all the benefits of synchronization that you could get if you were more synchronized. So yeah, it would be something interesting to look at. Okay, then we had a question saying, does preference for or ability to coordinate, act in synchrony vary across collectivist versus individualistic cultures? This is a great question. I would really love to know the answer. I can tell you that there are few studies, but it's really just a few that have not found any strong or reliable differences. So in terms of, but these were more studies, again, in terms of our tendency to integrate other people in our planning. So there, it seems that this is a very basic tendency and you find it more or less equally in different cultures. But I think this is, really a question that's far from settled because there are very few studies, and it would be really, really important, I think, to do more studies, either by, really collecting data in different cultural contexts, or also just by using some priming manipulations. So we recently started doing some work where we just tried to prime independence or interdependence to see what effects it has on task performance. And from, it's early days, but from what we see, that can induce, quite some changes. And so, for instance, I would predict that when it comes to, sort of deciding on a course of action where you consider what's good for your partner or not, what's jointly efficient or not, it really should make a difference whether you're more focused on yourself as an individual or whether you think more in terms of a group. So that could be one area where this could be explored.
Go for it. Simon, you were need to cut, or Diana?
Yes, really interesting work, really, really great stuff. So I was intrigued. In fact, it was something I I was thinking throughout your talk, because you did start with 2 people at a time and how they coordinate and all of that, but then you moved into how also others would be influenced by that if they observe it, and especially when you talked about synchrony and so on. I should say we've done some work on behavioral synchrony where we looked at people's responses to other prosocial behavior. So the extent to which we call it moral elevation. So when people feel inspired and, you know, uplifted, and they want to do good things too because they see someone else engage in prosocial behavior. And we found that that feeling increases when 2 people are in moving in synchrony beforehand. So it's as if it brings them together, and they then appreciate others' prosocial behavior even more. But at the same time, we also, in that same line of work, we found that when it's a more self-focused emotion like pride of having done something well, that actually is downplayed. So basically you want to get along with the other person. So you join up to kind of celebrate other accomplishments, but you downplay your own accomplishment because you don't want to be, you know, ahead of them. If you won on a game and they lost. So I think there's some really interesting effects of well, basically going beyond just those 2 people. And it made me wonder, what do you think is kind of, if you think of, okay, so people are definitely tuned into one more person, right? So to work in pairs, but then also you have the group aspect, others watching either them or they're watching others and so on. So what do you, how do you think it fits together in group context, or what is, or even what's a good group size, or how far are we still sensitive to these things when we're in a small group? Is 2 the most ideal level, or can we do 5 people or something like that?
Yes, I think that's a really important question. This question of, you know, to what extent do these mechanisms scale up to larger groups? And I guess there's no single answer, because it really depends on sort of which specific process we're talking about. I think when it comes to making predictions about others, of course, you know, if you think about it in terms of sort of fairly detailed predictions, there must be a limit to that. You can only do that for one, maybe 2 others. But I think one way in which, you know, this could be scaled up is if you think more in terms of sort of more distal action outcomes. So for instance, in music, if you have a whole symphony orchestra, of course, they are not just predicting, you know, the actions of, let's say, you know, the musician next to them, but I think they have an ability to sort of generate predictions that are about the group outcome. And then they are sort of trying to adapt their own actions, not only just to specific others, but to what the group as a whole is producing. So I think, you know, once people's planning is less focused on sort of the specifics of others, let's say movement parameters, and is more about these sort of more distal outcomes, a mechanism like prediction could actually scale up and be relevant for a large group of people coordinating together. And yeah, I think also phenomena like acting in synchrony, of course, that's clearly a phenomenon that may even be more relevant for larger groups. If you think of things like marching in synchrony, so that I guess a lot of, you know, these situations that then also raise interesting questions about, yeah, what does this do to your sort of, you know, sense of agency? There are all these reports, of course, also from anthropology about this sort of, you know, sense of losing yourself in something larger. And I think generally, you know, this sort of first part of your question, I think to me sort of highlights that it's really important to think more about the effective side of things, right? So what are our experiences acting together with other people, observing other people acting? So it's a really interesting finding that you have there, that synchronization has this sort of effect on how people experience this moral elevation. And also that, you know, pride is an emotion that's not so easily shared. So I think that that's something that has hardly happened in a way that people who are interested in these sort of very basic joint action mechanisms have tried to think about, sort of the affective dimension and people's emotional experiences. I think that would be something really, really exciting to look at more, because I guess sometimes you also get this sense in terms of agency that, you know, you're not achieving something as an individual, but you're achieving it as a group, right? So what does that mean, or what does it boil down to, and when does it happen, and when is it less likely to happen? So I think that would be really exciting to explore further.
In fact, one thing that I found really interesting when we did this work and looked at the literature is that actually joint action, well, synchrony rather, doesn't actually necessarily lead to more positive affect. So it's not that it makes you feel good, as in just generally good mood, but we found these more specific effects of very clearly social emotions, positive, I guess, positive social emotions. So it's really complicated, or not complicated. It seems like the system is finely tuned towards certain types of emotions that are appropriate in a social context or not, but it's very much about the collective as opposed to just oneself feeling good.
That's right. And as you say, I mean, it's actually hard to see any effects on mood. And a lot of studies have tried and not gotten these effects on mood. It'd be interesting to know also what happens in the context of joint improvisation, because I think there, people have this sense of a lot being at stake and things being very sort of fragile and perilous, and you could easily, lose the synchronization. And I think often that does come with quite strong emotions, because you're sort of synchronizing against the odds.
Right.
Interesting to look at that too. Yeah.
Really interesting. Thank you.
Thank you. So there's some more written comments.
There's more written. If someone wants to read, say their own question, they can, or then we make Natalie do all the work, read the question and answer.
I'm happy with the mixed format, so let's look at one of the written ones and then go for more.
I think it's Chantal, the next one.
Okay, have any neural correlates for synchrony and or asynchrony been identified in your research? There's some work by Christian Kieser and what's her name? Former PhD student. I can send you the paper, where they have tried to do some fMRI work looking at neural correlates. It's not, I would say it's not really straightforward. They try to sort of, look at mirror system activation and argue that you have more mirror system activation in the context of coordination, perhaps because you're predicting, your own actions in addition to your partner's actions. But there's really not that much. There's one very interesting study by Giacomo Novembre and Peter Keller and Günter Knoblich, where they actually used I think TDCS to stimulate two people's brains and tried to get them into synchrony at a particular frequency, and found that they were then more synchronous in their action onset when they were trying to tap at the same rhythm. So there's a little bit of work, but no, I think no coherent picture at this time. But do drop me an email and I'll send you the papers. And then there's a question by Diana. Have you tried to replicate these results on participants at different ages, teenagers, elderly, psychological conditions? I think it could be useful in generalizing, understanding some underlying mechanisms. Yes, by all means. Very little work on age. I know there were some plans by someone who's sort of specializing in studies of social cognition in older age, but I don't think anything has been published there yet. There's a little bit of work on autism. We actually did some work where we perhaps somewhat naively thought it would be easy to show that people care less about their task partner and sort of ignore their actions. But we tested individuals with autism who were very high functioning, and they actually, showed a somewhat surprising tendency to include their task partner in their actions. So their task performance was different from our control group in the sense that they were slower overall, but they did include the partner. And I think that there is now some, it's actually quite some work on autism coming out from Nirit Bauminger's lab in Israel. And there's also work on schizophrenia by I think Paula Fitzgerald. So again, I think it's a case where if you send me an email, I'll send some references in return. And I think again, the field is sort of at a stage where we have all these tasks, but they haven't been, you know, sort of very systematically tested with particular populations. And so you have sort of the occasional finding here and there, but we are sort of lacking, you know, a more coherent picture. So that there's, you know, really a lot that could be done. Okay, and then we have Bisma.
The speaker for next week. You know, show yourself. Ask the question, Bishma.
Good to see you. It's been a long time. The why question. Why does synchrony lead to prosocial behavior? Oh, I have a new PhD student who's interested in the question, and she's making me read all these, you know, review papers that are out now. So I can tell you that some people think it's about group identification, and yeah, that may be actually the sort of dominant account now. So for some reason, you know, someone acting in synchrony with you gives you the impression that they are part of your group, and that then, you know, in turn drives this more prosocial behavior. I think that's sort of one mechanism that has been proposed. There's also this sort of effective route for which we don't have that strong evidence. So some people, you know, used to think that, yeah, you sort of feel better when you're synchronizing with someone, and there's this sort of more, yeah, effective route towards prosociality, but the evidence for this, I think, is less strong. And then there is a sort of explanation that may be partly overlapping with this group identification idea, and that has to do with sort of self-other overlap and also self-other merging. So people thinking that if you synchronize, perhaps it is sort of a signal that you're not fundamentally different. You're just like the other. You're doing the same thing at the same time. And that could break down some barriers and even lead to some sort of self-other merging. And I think, you know, that would sort of predict perhaps sort of more specific prosocial effects towards the other, whereas something like group identification would predict effects that generalize at least to members of that group, to others who you think are affiliated with the person with whom you've synchronized. And then this sort of effective route would suggest that, yeah, it could generalize, you know, very widely because you're just in this sort of more cooperative state. So I think we do need, you know, more work to find out what's going on here. And what really bothers me sort of going through the literature is that people just take it for granted that synchrony is special, and they always compare it to asynchrony. But we don't really know what would happen, for instance, if people had to take turns. So if there was, you know, a high amount of coordination required, but not necessarily acting in synchrony. So I think that's also a big missing piece.
No, that's great. The only thing I was thinking, based on your explanation, is, I mean, if the explanations of why are all dependent on the self-other merging and group identity, then these processes are fairly complex processes, and I would imagine they come fairly late in development. So you shouldn't see the good impact of synchrony in early childhood and very early in development. But we do see quite a bit of rapport building that's happening very early on. So I'm wondering about that.
That's a very good point. Yes. Yeah. So either there is a sort of, either there's something happening, you know, in little kids that adults then sort of, you know, don't experience to the same extent. I mean, that could be. I think there are a lot of things that kids enjoy very much that adults, you know, don't feel so enthusiastic about, right? So it could be that this is sort of effective route that later kind of gets, you know, shut down for some reason. Or it could be that we just haven't run the right studies yet to actually find it, or not looked at the right sort of actions, perhaps. Yeah.
Thank you.
Thank you.
Good to see you.
Then we have Peter, who announces he would rather ask live.
Can you see me?
Yes, hi.
Okay, good. Well, more or less. I wanted to follow up on the sort of individualist versus collectivist question, but take a even more general perspective. I've been very interested in the concept of ideology. One of the best definitions I've found is that if we have an idea, ideology has us. So basically, it's those extremely complex and subtle values and principles, epistemological, moral, whatever, that we subsume and we absorb. So presumably, it would be analogous to being like a fish in water. So we don't know we have this ideological structure because it's always been around us. And as a side note, I'd also like to add, this is a big problem in psychology because given that we are both the subject and the object of study, this obviously will have. So yeah, I've just been wondering if cognitive psychologists in general have tackled this in this more sort of broader complex aspect? And on a second sort of notion, to what extent this relates to your work? So is this a prerequisite to joint action? To what extent? And
yes, I think you could argue that we have gone very social, and perhaps we have gone overly social. So and perhaps it's a bit of a counter reaction, right? So I think there was a time where, in evolutionary terms at least, people very much sort of bought into the idea of competition and, individuals having to eventually develop the cognitive skills to sort of handle deception, and sort of very much looking at things in terms of how people are getting sort of ahead of others, right? And so the idea would be that you need this kind of, competitive elements to explain how our cognitive system has evolved to be the way it is. And I think there was sort of, whether direct or indirect, there was a sort of, move in a very different directions, sort of highlighting the fact that probably from, very early on, we had to be very cooperative, and at least within our own group, it was necessary for survival to be very much oriented towards others and sensitive to others. And you could sort of say that there has been a social turn in the cognitive sciences, and, there are many different, sort of aspects of cognition that people are now trying to understand from a social point of view. And, whether it's comparative work or work with, developmental work or work on adults, people are much more willing to look at things in social context. So I see this very much because, I started out doing my PhD in 2001 or 2002. At the time, it seemed really strange to people that someone in cognitive psychology would care about, social interaction. And now it seems like, yeah, well, of course, and everyone is doing that. And so yeah, the fish in water thing, is well taken. You could say that perhaps now we feel so comfortable with this idea that everything is modulated by social interaction that we sort of don't really test these ideas to a sufficient extent against alternatives. But I think we are still at a stage where we're really trying to understand just the basic processes and the nuts and bolts. And for that, I feel that perhaps it is not so much of a problem, because I think joint action as a phenomenon is something that's definitely real. And I just feel like it would be good to understand, how it works. And for instance, also, if you wanted to build a robot that can interact with humans, you would want to know what kind of, principles do you need to implement. And I think that is, we're never free of ideology, but perhaps it's not something that's so much in the foreground or that I would worry so much about. That's the short answer to a complex question. Yeah.
Okay, thank you.
So the brave are here. You've been great answering questions. I haven't never seen someone like, oh, I read one. Oh, I do it myself. Like as if you could see the people.
Well, it's a lot of fun because we don't have so much social interaction these days. So.
Any more burning or thoughtful or comments, questions? People who are still here. Jeanette.
Hi, thanks for the talk, Natalie. I just want to follow up on the point you were making about the different kind of developmental story that there might be. And I was thinking that there's lots of work showing that infants prefer synchrony, they prefer partners who are moving in time with them, and not so much on other forms of joint action that are asynchronous. But I also was wondering about infant action and how this isn't necessarily smooth or continuous, that, you're talking about jitter, and I think a lot in infancy about jerk. And, maybe actually the actions that the infants are producing aren't going to be smooth and adult-like. Mm-hmm. And then I wondered what you would predict, therefore, an infant would prefer a partner that is synchronous to them, but with a similar level of jerk and jitter in their action, or a partner who was asynchronous, but with a smoother, and probably more intentional towards the same end goal as what the infant were producing.
That's really interesting. And I think you could really imagine some sort of preferential looking studies in infants in terms of joint action observation. It might be harder to do in a context where they are engaged in the joint action, but just in terms of observation, it'd be super interesting to know whether they have a sort of preference for these, movements that adults prefer that have low jitter and low asynchrony. And in terms of them being involved in the interaction, yeah, I guess you have different theories making different predictions, because if it is sort of about them being able to predict what the other is well, actually it's very complicated, because if it's about predicting the other, I was going to say that they might have an easier time predicting the other if they are acting in this somewhat sort of jerky way that they are acting. But then we know that generally smooth movements are much easier to predict. So it could be that they have this preference for smooth movements because they are more predictable, and also perhaps there's something to be learned. And perhaps, there is also this sort of effective component that you feel more safe. I think whenever someone is quite jerky, it often also indicates low confidence. There's some studies that have linked sort of, jitter and confidence. So they might have a preference for an adult who's, sort of more calm and has more potential also for regulating their own emotions. But I think it's really, really interesting, and would be really wonderful to be able to look into that.
Thanks.
Thank you.
A couple more questions before we close and go to our, I was going to say to our drinks, but at least I will go to my drinks, and next time you're in Cambridge, we'll invite you for drinks and dinner.
We'll have an extra drink.
Yeah, exactly.
That'd be good.
Any more? If not, I would like ask, comment something, ask you a question on this idea of the people who do harmony, the musicians, that they of course, synchrony, it's only a very small aspect that you want in musicians, but you want to be able to play together, and especially if you're if you know the song, okay, but if you're doing free jazz or or just improvisation, there's many other ways. And one thing that maybe Dan can help me here, there are ways to measure the level of information exchange, right? Mathematical ways that are not necessarily synchrony, classic phase locking and etc. And I was wondering whether it has been done also at in experiments, in cognitive experiments, because I've seen tons of papers about people measuring the level of information interaction in the notes that the different musicians play, but it's not very well controlled and it's very tricky, so we don't gain a lot from those studies. They are observational. Do you know anything about this side of the idea of information processing between two agents that are supposed to be interacting effectively? Or
so one sort of piece of work that might be interesting in this regard is by Couturier, who's at this music, whatever you call it. I'll send you the link. It's a group of people in Paris who sort of study coordination also in people who do free jazz, for instance, and they sort of looked at what the optimal level of common ground is. So on the one hand, people seem to be playing together very well with people whom they know very well and with whom they've played for a long time. But on the other hand, there is also this tendency to to play with someone you don't know at all, right? So that in a sense you can get away from this baggage of common ground that limits your creativity. And I think they sort of went beyond something that's sort of purely descriptive and tried to do at least sort of an analysis that sort of is based on this idea of common ground that people have when they're playing together. So that might be going a little bit in that direction, but I think it is a pretty hard problem. So there's probably not a coincidence that you have this literature that focuses much more on the product in a way, right, and on the music side of things, and doesn't talk so much about the cognitive processes. And then you have these cognitive studies that are much too simple to account for something like free jazz. So there's not a lot of middle ground. But I think, Couturier and the people working with him might be one group that's sort of tried to create this bridge. Yeah.
I look it up. Yeah, I definitely, don't think it has been solved. The cognitive neuroscience of free jazz, it sounds pretty difficult.
Yes, I mean, any study of creativity just in individuals is super difficult, right? And then when you take two people, it doesn't get any easier, or more people. Yeah. But I think there are also things like for instance, polyrhythms that are quite suitable perhaps for studying sort of more complex musical interactions. but still give you enough experimental control. So that, I think that's sort of a direction in which, you know, one could move. So to have something that's much more interesting than just synchrony, but yet
completely
you can understand.
Yeah, that's what I was thinking. And you know, seeing some people that were still here, you know, sort of also triggered me the questions. You know, Bhishma, you know, plays complicated stuff with his group, and Peter, you know, anyway, unless there's a burning question, guys, today. If not, of course, you can send an email to Natalie or find her in all sort of other social, you know, systems. Zoom, Skype.
Yeah, email is best, actually. Many thanks for all the great questions. It was really a pleasure.
Yeah. Thank you very much.
Take care, everybody. Bye. Thank you, Tristan.